Hello everyone, myself Vaibhav Thombre and my today's topic is technical. So my topic is the memory allocation in Java. So in Java, the memory allocation is handled automatically and by the JVM. So this memory management system is designed to make Java applications efficient and memory safe, and it can reduce the risk of memory leaks, and the segmentation faults commonly founded in languages like C, and in Java's memory allocation, which was divided into several main regions with its specific purposes, such as a heap memory, stack memory, method area, and additional smaller memory regions. In the heap memory, the heap is the main area for dynamic memory allocation and where most Java objects live. In heap memory, it was shared by all threads, making it the primary spaces for storing instances of classes and arrays. In heap memory, it's what in the JVM, it was splits into some several generations, such as it was young generation. In that, this is where all objects were allocated, and the garbage collection cycle to the next. The JVM keeps this track of how many garbage collections and objects has survived. In that, if it is reaches a certain threshold, it moves to the old generation, and in that young generation, it was subject to the minor garbage collection, which was quickly clear the short-lived objects. So in the garbage collection in the heap, the garbage collector it was recalls the memory from its objects and that are no longer reachable. When Java provides several garbage collection algorithm, each tell for the different needs. In that the stack memory is used for method execution, and it was holds local methods. In that the stack memory is allocated in the last in first out, which was called LIFO, and when the method is called, a stack frame is created for its and this frame contains a local variable, return address, and once the method finishes the execution, its stack frame is popped from the stack and freeing up memory. Since the thread it's on the stack, which was a memory was a local variable, is confined to the thread, which reduces need for the synchronization. So the next one is a method area. In that, the method area sometimes called a class area or meta space, in the which was store metadata about the classes and the uh, uh, which was contain some statics variable. In that, the variable that belong to the class rather than uh, in that classes was created in the space. So the method area, the sometimes it is called the area or the meta space. So in that, the class level data, it's we have the informations which was about loaded the classes and such a field and the method names, consistency, visibility, and it has some types in that, such as a constant pool, static variable, and compile code was doing their generated task. In earlier the JVM, which was implementation, the method area had a fixed size and was prone to the out of memory errors. With the advent of the metaspace, the method area can dynamically expand and reduces out of the memory issue. So the in that, the additional memory areas, it's beside the main memory areas, such as the JVM has a several smaller regions, it was a PC registers. In that, each thread has a PC register that tracks the current instruction addresses, and this register is essential for maintaining the execution state of a thread, especially when the yield or the switch contains. So the next was the native method stack. In that, the Java can call all non-Java means native code like a C or C++ function. That native method stack holds information which was specific to the native methods call, such as the data, memory, and in that, it has a main references used by the native code. The next one was the memory management mechanism in Java. It was the Java uses automatic memory management, which includes garbage collection to handle memory allocation. However, for the developers, it can optimize memory allocation by some following some set. In that is included, such as avoiding necessary objects creation. In that, it can reusing objects where possible, prevent excessive memory consumption. In that, the memory allocation, the Java memory model is geared towards ease of the usage, such as in that efficiency and safety, with the JVM handling most of the allocation and deallocation process. The memory management technologies like garbage collection, stack-based memory for quick allocation, and the deallocation, and the heap memory for dynamic object management. It can make the Java a popular choice for developing memory safe and scalable application. The combination of structured memory model and the advanced garbage collection strategies, it was enabled Java to efficiently manage the memory for optimizing the applications. This was all about the memory allocation, which was can create the Java most usable language in the for the developers. So thank you.